Suprabhat. Today we are going to learn about divisibility test. We all are very familiar with the divisibility test of 2. What is it? If units place is divisible, then it is divisible by 2. That is 0, 2, 4, 6 and 8 are at units place. For 4, we have to check last 2 digits. For example, 24 is divisible by 4. Therefore, any number 31 to 4 is divisible by 4. Because last 2 digits are 24. We can write any number before 24. For 8, we check last 3 digits. For example, any 1000 is divisible by 8. For example, if I take 7000, you may think that 7 is not divisible by 8, but there are 3 zeros, so it is divisible. It is certainly divisible by 8. Let's check 7000 divided by 8. So 8 8 is 64, 60, 8 7 is 56, 40 and 8 5 is 40. So 7000 is completely divisible by 8. We have checked. Similarly, as we go here, it can be written as 2 to the power 1. It can be written as 2 to the power 2. It can be written as 2 to the power 3. If I check for 2 to the power 4, that is 16, then obviously one more 0 should be checked. That is, every 10,000 is divisible by 16. And so on. Now let us check another divisibility test. What are other divisibility tests? For example, the very first test for 3. We all know that if sum of numbers, sum of digits is, for example, if number is 3, 4, 7, then 7 plus 4, we check 3 plus 4 plus 7 is equal to 14. This is not divisible by 3, and therefore 3, 4, 7, 3 is not factor of 347 or 347 is not divisible by 3. How do we decide that only sum of the digits is able? Let us take A for 3, B for 4 and C for 7. We can take any number of digits, but for simplification I am going to take the 3-digit number. Suppose A, B, C, D is a 4-digit number, is a number. Here there is no product. This is the place value of the number. That is, A, place value of A is A into 1000. Place value of B is 100B. Place value of C is 10C. And place value of D is D. That is, the number is actually this. ABCD is a number whose value is this. This can be split into different ways. We are going to split as 999A plus here 99B plus B plus 9C plus C plus D. Now we are going to collect all single. that is equal to 999A plus 99B plus 9C plus A plus B plus C plus D. Now we can take common 3 from these all 3 numbers. That is equal to 3 into 333A plus 33B plus 3C plus A plus B plus C plus D. Now sum of two numbers. One number is completely divisible by 3 because 3 is factor here. So what we have to check? We have to check only A plus B plus C plus D. If it is divisible by 3, then the whole number ABCD will be divisible by 3. Because this number is completely divisible. This number, remaining number is completely divisible by 3. This also can be further further increased to 9. We can take 9 common. It can be written as 9A111A plus 11B plus C plus A plus B plus C plus D. Now if sum of the numbers is divisible by 9, A plus B plus C plus D is divisible by 9, then the whole number will be divisible by 9. Did you get my point? You can check, verify. If you know the reason behind the divisibility test, then it becomes very easy to understand and learn. Later on, next test is test for 2. 6. 5 test, it can be easily seen that if there is 5 or 0 in units place, then it is divisible by 5. Because if we look at the table of 5, there are the only numbers there are 0 and 5 at units place. Tens place can vary or hundreds place can vary to any digit, but at units place the only digits are 5 and 0, and therefore it is divisible only if 5 and 0 is at units place. Next is 6. Divisibility test for 6. Now what can you say about 6? 6 is not a prime number. So it can be divided into its prime factors. It can be divided as 6 into 1. No, but here we cannot say every number is divisible by 1. So 1 cannot help to any number. So another factors are 2 into 3. Now look at it. HCF of 2 and 3 is 1. Therefore such factors are called as co-prime factors. If 2 and 3 co-prime factors and a number is divisible by 2 and 3 both, that we can apply the test of divisibility of 3 and 2 to the number. Then the given number is certainly divisible by 6. For example, 4, 7, 8. Let us take. What is 8? It is 8 is at units place. Therefore, it is certainly divisible by 2. Now, 8, 7, 15 plus 4, 19. It is not divisible by 6. Sum of the numbers 4 plus 7 plus 8 is equal to 19. This is not divisible. Therefore, this number will not be divisible by 6. Let us check. 6. It is not divisible. Did you get the point? Okay. Another number. Let's check. This 478. I will take 438. I have reduced 7 by 4. Now sum of the digits is 4 plus 3, 7. 7 plus 8, 15. And 8 is at units place. It is divisible by 2 as well as 3. And therefore, let us check. 6. So it is divisible by 6. So if we check for co-prime numbers, in that case, if a number is divisible by 2 co-prime numbers, 3 co-prime number, then the number is divisible by product of that co-prime numbers. Their HCF must be 1. Next, 7. We have to subtract double of last digit from the remaining number multiply so that we get the divisibility test for 7. 8 we have discussed, 9 we have discussed. Now we are going to discuss about test for 11. All of you may be familiar with the test of 11. That is sum of alternate digits. Difference between the sum of alternate digits is divisible by 11, then the number is divisible by 11. Let's find. Take any number A, B, C, D, E. 5-digit number we can take. It doesn't matter. So this number, these are digits at that place. So actual value of this number is 100,008 plus D plus 100C plus 10D plus E. Actual value of this digit is 10,008 plus 1000B plus 100C plus 10D plus E. Now we have to find the divisibility test for 11. We will find which is the nearest number to 10,000 or 1000 which is divisible by 11. For 10,000, 9999A. This 9999, this is divisible by 11. 11 9s are 9, 0 and 11 9s are 99. So this is divisible by 8. So it is split as 9999A plus A. But for 1999 is not divisible by 11. So what could be the next number? Here the funny number you must be knowing. 1001 is equal to 7 into 13 into 11. There are many funny jokes or just tricks by using this number. So 7 into 13 into 11 is equal to 1001. One must remember all time this number. That is factors of 1001 are 11 into 7 into 13. So this number can be taken ahead. So we take 1001B, but our number should not change its value. So we have to subtract here B. Plus again 99C. 99 is divisible by 11 plus C. Again 90 is not divisible by 11. So here we take 11D minus D and plus C. Now as we have taken the numbers as they are, we will write the numbers in collaboration. That is 9999A plus 1001B plus 99C plus 11D plus, what is here? A. This is minus, we will take in another bracket. This is C and this is A. Minus B minus D. Now we know that this number is divisible by 11. That is 11 in bracket 101A plus 91B plus 9C plus D. plus A plus C plus E minus B plus D. Now this factor is completely divisible by 11. So remaining should be divisible by 11 so that the whole number A, B, C, D, E will be divisible by 11. What is A? A is digit at 10,000 place. What is C? Digit at hundreds place. What is E? Digit at units place. And what is B and D? Those are alternate digits. So here comes the divisibility test for 11, that is if the difference between the sum of alternate digits is divisible by 11, then the number is divisible by 11. Did you get the answer? Now next is 12. Now 12 is not a prime number, so we will factorize it and its co-prime factors. There can be many factors: 1, 12, 2, 6 and 3 into 4. These factors are not useful for finding the divisibility. Here HCF of 3 and 4 is 1. Therefore, a number divisible by 3 and 4 is divisible by 11. For example, take any number. Now this, as I have taken 24 purposefully, this 24 is divisible by 4. Therefore, the whole number is divisible by 4. Now 1 plus 2, 3. 3 plus 6, 9. And that gives us this number is divisible by 12. If it is not so, suppose I take here another number. For example, 14. Now 6 plus 4, 10 plus 1, 11. This number is not divisible by 3. So it will not be divisible by 12. So it is not divisible by completely divisible by 12. Did you get the answer? Okay. Why should we take co-prime numbers? Why cannot we say that if a number is divisible by 6 and 2, then it is divisible by 12? Let's check. Suppose a number is divisible by 6. Suppose first we take 24. Now it is divisible by 2 as well as 6. So 12, it is divisible by 12 also. But if I take 30, is it divisible by 2? Yes. And is it divisible by 6? Yes. But is it divisible by 12? No. So we cannot take such factors where the factors are not co-prime. If the factors are co-prime, then and then only we can say that if a number is divisible by the two factors, then the number is divisible by its product also. For example, a number divisible by 9 and a number divisible by 4, then the number is divisible by 9 4 the 36 also. 1, 2, 9, 6. Now as 9, 6 is divisible by 4, so it is divisible by 4. And 1, 2, 9, 6, sum is 18. 1 plus 2 plus 9 plus 6 is equal to 18. So it is divisible by 9 also. Therefore this number will be divisible by 9 into 4, 36 also. Because here HCF of 9 and 4 is 1. After that, from here, after the numbers, prime numbers, we have to just check and we can find co-prime factors for different numbers to check the divisibility test. For example, 14 can be written as 2 into 7, 15 can be written as 3 into 5, 16 we know, all 10,000s. 17 it is prime, so we have to divide as it is. 18 can be written as 2 into 9 co-prime factors. 20 can be written as 4 into 5 only co-prime factors. 21 can be written as 3 into 7. 22 can be written as 2 into 11. 23 is prime, so we have to divide by itself. 24 can be written as 3 into 8. 25 can be written as double square of 5. Okay, thank you.